right, I think we're going to go ahead and get started. Can everybody hear OK? Awesome. So today I'm going to tell you all about building iOS apps with Firebase. Just a quick show of hands. How many of you have heard of Firebase before? OK, about half the room. How many people have built an app with Firebase? All right, just a few of you. Before we get started, a little bit about myself. I am a developer advocate on the Google Cloud Platform team. My name is Sara Robinson. You can find me on Twitter at @srobtweets. And I live here in San Francisco. I'm a Swift fan, both Taylor Swift and the language Swift. If I had to choose a favorite, it would be a tough call. All my code samples and demos today are going to be in Swift. And when I'm not programming, I can be found finding the best ice cream in San Francisco. So here's what we're going to cover today. First, I'll give you an overview of what Firebase is. Then I'll talk about specifically how to get started with Firebase on iOS. And we'll do a quick real-time chat demo. Then we'll do another demo of a visualizer for the Cloud Vision robot using Firebase on iOS. And then we'll wrap up. Before we dive into the agenda, I want to start by telling a story. So about a year ago, I didn't know any native mobile development, and I really wanted to learn. I had done a lot of JavaScript. I had done some stuff with hybrid mobile frameworks, which lets you write HTML, CSS, and JavaScript, and it runs in the native web view. But I had never done any native mobile development. I've been an iPhone user for a long time, so I decided I wanted to learn iOS development. And I had a couple of requirements. I wanted a way to learn that I could learn pretty quickly and focus on learning the iOS-specific aspects of development. So I wanted to learn how Xcode worked. When I built apps, I didn't want to have to focus on spinning up servers or working on my backend infrastructure. And Firebase turned out to be a really great tool for learning iOS development, which is why I want to tell all of you about Firebase today. So now back to the agenda. What is Firebase? Firebase is a platform for building extraordinary apps. But what does that mean? Firebase consists of 3 core features. And the first of those is the real-time database. I'm going to talk about all these in detail. But the Firebase database is a NoSQL JSON database. And every piece of data stored in Firebase is referenced by a URL. The second feature of Firebase is user authentication. So how many of you have implemented OAuth before? A few of you. How many of you enjoyed it? One person. It's not very fun. But the cool thing about Firebase is Firebase makes user authentication easy. So we take care of OAuth on the Firebase servers. All you have to do is one method call, different on each platform, and you've got users authenticated. You'll see that in the demo shortly. And then the last feature Firebase offers is static hosting. So this is a tool for web developers to deploy static content, HTML, CSS, and JavaScript through the command line with just one command, Firebase deploy, and your app is live on your own firebaseapp.com domain. So let's take a look at the real-time database. First, I want to talk about the ability of Firebase to allow devices to talk directly to the database. So what we have here is your traditional application architecture. We've got a device that talks to an application server, which is running your application logic. And then this, in turn, talks to the database. With Firebase, the architecture is going to look a little different. With Firebase, we have a 2-tier architecture. So your device can talk directly to the Firebase database. And this simplifies development a lot. With this 2-tier architecture, development is much faster. So typically, building real-time apps is something that's pretty difficult. We have things like Google Docs, where users are adding notes to documents in real time. There's a team of hundreds of engineers behind that. With Firebase, you can build real-time apps as just a single developer or a small team of developers. So development is really fast. And then Firebase handles all of the hard parts for you. So you don't have to worry about scaling your app from your first 10 users to your first 10,000 if your app is a smash hit. Firebase will take care of the scaling part for you. But sometimes you will want to run trusted server code. A lot of the Firebase customers do. So Firebase has a REST API that lets you connect your server code to Firebase. And it's also really easy to wire up third-party APIs with Firebase if you'd like to do that. So my favorite part about Firebase is the real-time data synchronization, which you can see from this awesome GIF. So the cool thing about Firebase is that any client that is connected to your app shares one master copy of the data. And any client that's subscribed to that will see data updates in real time. So you don't have to pull to refresh on mobile. You don't have to refresh the page on the web. Data is synchronized in real time, which is really cool. So I've talked a little bit about it. Let's look at some Swift code on how you would store and sync data in Firebase. So as I mentioned before, every piece of data in Firebase has its own URL. So to create a reference to your database, you say let ref, so it's going to be a constant here, of type Firebase, and you pass it a URL. This is the URL I'm going to use for this demo. And there's two ways to write data to Firebase. The first is set value in Swift. And what this will do is it'll update the location with whatever you pass it. You can pass it a string, an object, a number, a Boolean, and it'll update that. So set value is useful in certain situations. Sometimes you'll have a lot of people writing to the same path in your Firebase database at the same time. And in this case, you'll want to generate a unique ID each time a new piece of data is added, which is where you'll want to use this method child by auto ID in combination with set value. So here what we're doing is we're saying ref.child by auto ID, which is going to create a path at the root of your Firebase / a unique ID, which is going to look something like what you see in the comment there. And then you're going to set the value at that path. Here we're just setting it to a string, hello again. So that's how you write data to Firebase. To read data back is pretty simple. You just attach this asynchronous callback to your Firebase reference, and this will be triggered anytime the data at that location changes. So you pass this listener an event type. Here we're using the value event type. This function is going to be called anytime the value at that Firebase location changes. And because Firebase is a real-time data stream, it's always changing, this will be passed a snapshot. So it's a snapshot of your data at that specific point in time. And here we're just printing the value of the snapshot to the console. So now let's take a look at Firebase's authentication feature. Firebase has 3 different types of authentication. You can do basic email password auth, and you can also integrate with a number of third-party providers. So if you'd like to add Google, Facebook, Twitter, or GitHub auth to your app, it's really easy to do this with Firebase. All you need to do is register your application with one of these services, grab your API key and secret, head on over to your Firebase dashboard, paste your API key and secret in there, and then just one method call, you're able to authenticate users really easily. And then finally, Firebase offers anonymous auth, which is great if you want to require user login without having users type in credentials. So if you want to generate guest user accounts and still have some notion of securing your data without requiring users to log in. Let's take a look at some code here. This example, we're using GitHub authentication. So we just call the method auth with OAuth provider. We pass it the provider we want to use. In this case, it's GitHub. We'll pass it our access token. And then this is going to return either an error or an auth data object. The auth data will contain a bunch of data from the GitHub user's profile. And so you're probably wondering, if I'm talking from the device directly to the database, how do I secure my data? How do I make sure that people can't write to other users' nodes? And the way you do this is through security rules. So Firebase has a powerful security language. All of the security rules are run on the Firebase servers. And they're written in a JSON-like syntax that's going to match to the structure of your data in Firebase. So let's say you have a /users node in your Firebase. That $variable $UID signifies a dynamic path. So this rule is going to apply to any child of /users. And there's 3 types of security rules in Firebase. The first is a read rule. So this is saying that the data at /users/UID is globally readable. Anyone can read the data, but it's only writable by that specific user. So when you use Firebase authentication in combination with security rules, you automatically get access to this auth variable. So I can do things like say only this specific user can write to their own user node. So this makes it possible to say that you can't spoof other users in the app. The third type of rule is a validation rule. Those are run after the write rules succeed. So you can do things like verify that the new data is a string, is a number, adheres to a certain length, and things like that. So a common problem on mobile is what if your application goes offline? So let's say you got a chat app that you built, and your users are on a train that goes through a tunnel. They lose connectivity. They're climbing a mountain. They're on a plane. Wherever they may be, they're going to expect that their app will work offline. So how does Firebase handle offline situations? So any data sent while offline is persisted to disk in Firebase, not just to memory, which is really powerful. And when you regain connectivity, all of the data you sent while offline will be synced with the Firebase servers, and you'll also pull down any data that was sent while you were offline. So I can talk about offline disk persistence, but it's better demonstrated with a demo. And I didn't want to turn my Wi-Fi off during the presentation, so I've pre-recorded this one. So what you're going to see here is we'll add one message while we're online. Then I'll turn the Wi-Fi off, add another message, and then you'll see what happens when I turn it back on again. So let's go ahead and play this video. So we can see I'm online right now, adding a chat message. It was added to Firebase, and now I'm turning my Wi-Fi off, adding another message. Here we go, hello from the other side. And it was added to my app. I quit the app. Wasn't added to Firebase yet because I'm still offline. We can see it's still saved there. I'm turning my Wi-Fi back on, and boom, it was added to Firebase. So that's a quick demo of how Firebase offline works. And to enable this, you just need one line of code. This is what it looks like in Swift. So you just say firebase.defaultconfig and set persistence enabled to true. That's all you need to do to get that working. And then optionally, you can specify that data at a specific location in your Firebase should be prefetched and kept up to date. And you can do that with ref.keepsynced and set that to true. So now I want to talk about the third feature of Firebase, which is the static hosting service. And this lets you deploy your static assets through the command line with just one command, Firebase deploy. And all of the content is served over HTTPS by default. Firebase takes care of acquiring the SSL cert for you. It's backed by a global CDN, and custom domain support is available. So by default, you get access to your own firebaseapp.com domain. You can easily configure a custom domain if you'd like to host your personal site on Firebase. It's really easy to do this. Once you've installed the Firebase command line tools, you just need to run Firebase init. This will initialize your directory with Firebase hosting. You only ever have to run that command once for each project. And then after that, to deploy is just one command, Firebase deploy. It's really fast. So just to summarize, Firebase has 3 client libraries, iOS and Android libraries for mobile. I'm going to be focusing on the iOS client today. And then a JavaScript client if you'd like to build web applications with Firebase. And if you're a JavaScript developer, Firebase has libraries for integrating with popular front-end frameworks like Ember, Angular, Backbone, and React. So you can use those frameworks for the front end of your application and then store all of your data in Firebase. And then Firebase also has a REST API, so you can access it from your favorite server-side language. So now I'd like to talk specifically about how you can get started with Firebase on iOS. Any iOS developers in the room, just out of curiosity? OK, a handful. The easiest way to use Firebase on iOS is through Cocoapods. For those of you that aren't familiar, Cocoapods is the iOS dependency manager. And so the way you do this is you add Firebase to your pod file. This is where you describe all of your dependencies for your application with the correct version. Then you go to your application directory, just run the command pod install. That will install all the pods you've defined in your pod file. And then be sure to open the XC workspace version of your project, which will include all of the pods for you. And then in your view controller, if you're using Swift, all you need to do is add a Firebase import, and you're ready to go. So now we're going to go into a live demo. What are we going to build? We're going to build a simple real-time chat app, and it's going to look something like this. Similar to the video I just played, it'll be a basic UI table view, which is just a list. When you click on the plus sign, you'll be able to add a new message, and then the messages will be displayed in the table view. We're going to use anonymous authentication in the application so that I can show you a little bit about how Firebase authentication works. Why would you want to use anonymous auth in an app? Let's say you have a situation where you don't want to require users to log in, but you want to have some form of auth, so you want to have guest accounts. Anonymous auth would be great for that. And also with anonymous auth, you still get access to Firebase's security rules. So if you want to enforce security rules without requiring user credentials, anonymous auth is a great way to go. So I'm going to quickly show a video of how to install Firebase with Cocoapods, and then we'll get up and running with some code. So we're running pod init. This will create a pod file for us. So now I'm opening the pod file, uncommenting those lines, and adding the Firebase pod with the correct version. And I'm going to save and close the pod file, and then run pod install. I'm installing Firebase. And now I can see the XC workspace version of my project, which I'm going to open. And that is it. That is all you have to do to install the Firebase pod. So now if we could go to the demo. Cool. So I've already got a version of this application running that doesn't use Firebase. Let's run it in the simulator and see how it goes. There we go. So I'm going to add a chat message. I'm going to say hello. You can see it appears there. I'm going to say hello again. It's there, but if I quit the app and reopen it, my message is gone, which is kind of sad. It was only saved locally. We want our chat data to be persisted somewhere, which is why we want to add Firebase to the application. So let's see how we would do that. So as you saw in the video, all I need to do is add a Firebase import. I've already installed the Firebase pod. And then the next step is to set up my Firebase reference, which is going to go to this URL. And let's actually take a look at that URL in the browser. So this is what my Firebase database looks like. Let me make that a little bit bigger. This is where all the data for my application is going to be stored. I haven't added any security rules yet, but I'll do that shortly. And in the login and auth tab here, you can see that if I go to anonymous auth, I have it enabled, which means I have access to that function to authenticate users anonymously. Let's go back to the data and to the application. And the first thing we want to do is, instead of adding the messages to our local messages array right when the alert controller is cleared, we're going to add that in a different function. So I'm going to get rid of this. We're not going to reload the table view there anymore. We are going to instead do that in this push to Firebase function. So what we have here is a local messages array, and that's what we're using to populate our table view. So if we go down here, before we write that push to Firebase function, the first thing we want to do is authenticate our users. And we're going to do that in view-did-load. This is called only once in our application lifecycle. So I'm going to say ref.auth anonymously with completion block. And what this is going to do is it's going to return an error and an auth data object. And here we're going to say if error is not equal to nil, so if there's an error, let's just print the error to the console. Otherwise, let's print auth data. Obviously, we want to do something else with auth data, but I'm just going to show you what that auth data object looks like first. So here we can see we've got this auth data object with our unique ID for that session. So instead of printing it, I'm going to say self.uid equals auth data.uid. And this self.uid is a variable I've defined up here. So now that we've got users authenticated, the next thing we want to do is push that message to Firebase with the user's UID. So I'm going to create here an object that's going to have a key of text and a value of text, which is the text that the user has inputted into that message box. And then we're going to have a key of user, which is going to have a value of that UID that we set up here. And then to write this data to Firebase is just one line of code. So I'm going to say ref.childByAutoID. And I'm using child by AutoID here is because I'm going to have a lot of messages being sent if this app is a smash hit. And I want them to each have their own unique ID. So I'm using child by AutoID. And then I'm going to say set value message data, that data object that I've defined right here. So let's run this again. And I think it would be cool if we had Firebase side by side here with our chat demo. So I'm going to say, hello, GCP next. And we can see that my message is added to Firebase, just one line of code with my unique anonymous user ID. If I add another message, hello again, we can see that it was also added to Firebase, which is pretty cool. But you'll notice that nothing updated in our UI, because we haven't written a listener to read data back from Firebase yet. So that's what we want to do next. So going back to the code, we're going to do this in view-did-appear. And what we're going to do is we're going to, every time the value at this Firebase is updated, we're going to add the messages to this local array. And then we're going to update the messages array up here to contain the contents of that local array so that our table view will have all the latest message data. So here I'm going to say ref.observeEventType. And here I want to use the child added event type. Instead of value, this will be triggered anytime a new child is added to my Firebase reference. And here we're going to get back a snapshot. And first, let's just print the value of that snapshot so that you can all see what it looks like. This will be called once for the initial data, and then it's called again anytime the data changes. So let's play that. And we can see what we got back here is all of the objects which are currently in Firebase. So instead of printing it here, what we want to do is we want to grab the value at the text and add that to our local array. So let's write the code for that. So we're going to say let message text equals snapshot.value object for key is a method we have access to. And I want to grab the object at the key of text. And I know that's always going to be a string, so I'm going to downcast it to a string. And then I'm going to say local array dot insert message text at index 0. I'm using an insert here instead of a pen because I want to show the most recent messages first. So I'll insert it at index 0. And then I want to say self.messages equals local array. So I'm going to set the global messages array to this local array, which I'm using to populate my UI table view. And then I'm going to say self.tableview.reload data. I'm going to reload the table view data. So let's see this in action. We're building it. And here we have in the simulator, we rendered all those messages that we just sent. So let me, again, pull up Firebase side by side. And let's see what happens when I add a new message. Woohoo. You can see that my message was added in real time, and it was also added to Firebase, which is pretty cool. So we've enabled real-time sync with just a couple lines of code. And just to quickly show you the cross-platform nature of Firebase, what I've got over here is a JS fiddle. And so I'm going to write a super simple JavaScript application that's connected to the same Firebase, and we'll see it update in the simulator. So here I'm just going to use JavaScript. I'm going to say var ref equals new Firebase, and I'm going to create a reference to the same Firebase, gcpnext.firebaseio.com. And then I'm going to say ref.push. Text is going to be hello from JavaScript. And let's run that. And we can see that updated here. And it was also added in Firebase. But one thing you'll notice is that it doesn't adhere to this schema that I was following here, where it has a text and a user child key. And this is where security rules would come in handy. So with security rules, you can see over here, I'll make this full screen. By default, my Firebase is globally readable and writable, which is not good. That means anyone can read and anyone can write to the database here. So I should add some security rules. So I'm going to do that now. So I'm going to use a $ variable to say that for any child of the root of my Firebase, this rule should apply. So I'm going to say to write to this node, we have access to new data is going to be whatever data is added. New data.hasChildren. And then we're going to say that it needs to have a text and a user key there. So if I save the rules are saved, and I go here to the JS fiddle and try to add the data, we'll see that it did not succeed because of my security rules. But if instead I come in here and say user Sara and run this, it was called again. So now we're adhering to my security rules. One other thing I'd like to add in my security rules here is I want to make use of the authentication, which I've added. So I want to say that auth cannot be equal to null. So you need to be authenticated to write to this Firebase. So now if I go back to my fiddle and try to run this, even though this has a text and a user child key, it's not going to succeed because I'm not authenticated from the JS fiddle. So I just want to show you how easy it is to build cross-platform apps. You can easily build an iOS, Android, and web app that all do the same thing as long as they're connected to the same Firebase database. And again, we did that in just a couple lines of code. So if we could go back to the slides. Thanks. Let's see another app. So you saw a pretty simple use case, a real-time chat app that updates a UI table view. Let's see an app that's a little bit more complex. The next thing we're going to look at is an app I built, which is a dashboard for visualizing the cloud vision robot. How many of you have been outside and seen the vision robot at the conference? Cool. If you haven't yet, there's still time to check it out after my talk. For those of you that haven't seen it yet, you're probably wondering, what is this cloud vision robot you're talking about? It is an image detection robot, which is powered by the Cloud Vision API. It looks like this. Its name is VBot. And this is a little bit about how it works. So it's a Go robot that has a Raspberry Pi running on it. And the Raspberry Pi is running some Python code. You can think of the Raspberry Pi as the brain of the robot. And the Raspberry Pi also has a camera connected to it. So the camera takes a picture of whatever's in front of it. And then it sends it to the Cloud Vision API, which is able to return a bunch of metadata on what's in the object. So we're using the Vision API's label and face detection features here. to return some JSON on what's in the image. So if there's faces in the image, it can tell where they are, if the person is happy or sad. If there's objects in the image, it can tell what those objects are. So the Vision API returns this JSON response, and then we write that JSON data to Firebase, and we're using Firebase to power the web dashboard. So if you've seen the Vision bot, you'll see a dashboard that looks something like this on the monitors nearby, and it displays the latest picture that was taken with the bot along with the words that it's seeing. So we've got a web app to visualize the robot, and what we want to add is an iOS app. So I've taken the robot to a couple of events so far, and I thought it would be cool. Sometimes I'm walking between different demo booths, I'm walking between venues, and I want to check up on the bots, make sure they're all up and running like they should be. So I thought it'd be cool to build an iOS app that does something similar to what the web app does. This is what the app is going to look like. It's going to be a basic master detail view application. So we've got a UI table view that's showing the ID of all of the active bots. And then when you click on one of the IDs, it'll show the detail view of what that bot is looking at. So there's a picture I took at my desk a couple days ago. You can see it recognized my face and that I was smiling, so it drew a green box around my face, and I was holding up a bottle of water. The Vision API was able to identify that as a bottle of water. So what is the data going to look like in Firebase? So at the root of our Firebase, we have a /bots node, and then under that, we have all the IDs for our bots. And whenever one is updated, we want to change the color of that cell and display how long ago the bot was last active. So here, if it was active in the last 60 seconds, I'm displaying an active now. That's what the table view looks like. And this is a simplified version of what the table view controller code will look like. So the first thing we're doing is creating a reference to our Firebase. And then we're going to create a local bot array of fdata snapshot. Fdata snapshot is the data type of the snapshot that is returned from Firebase. And then what we want to do is we want to sync that data from Firebase into a local array. So this is pretty similar to what I did before, but we're listening on the value event type. And then we're going to loop through all the bot IDs. So we're going to say for bot in snapshot.children, and then within this function, we're going to sync all the data to a local array. And I'll show you it in Xcode momentarily. So then what will the data in our detail view look like? So this is all the data we're storing for each bot, a bunch of different data. And this is all data that's returned from the Vision API. So if you look at that /face node, the Vision API returns a bunch of data on the emotions that it detects in the image, where specific features are in your face. And then we're storing all this in Firebase, along with the base64 encoded image string of the latest image. And then we're also storing all the labels that the Vision API finds in Firebase. So we want to loop through those labels and display them. The Vision API also returns a confidence score of how confident it is that it found that specific label in the image. So we'll display that in the UI as well. And this is what our detail view controller code will look like. So we create a reference to, not to the root of our Firebase, but to the specific path for that bot. So this is going to be /bots/whatever bot ID. And Firebase references are inexpensive to create. So we can create a new ref for each bot when that bot cell is clicked. And so then on that bot ref, we're going to listen again on the value event type. And then we're going to grab all the data that's being returned from the Vision API and store that in a Vision data object. And then we're going to get the base64 encoded image string. We want to decode that and then display it in our UI image view. And then we're going to get all of the labels. And then we're going to loop through the labels and display those in the UI as well. So just to show you what the format of the data looks like, I've got a few sample responses from the Cloud Vision API. So this is a picture I took a couple months ago of some beignets in New Orleans. And I was pretty impressed with the Vision API's response. It was able to identify it as a beignet, even though it's a super close-up photo that may not even look like dessert. But it said beignet, it was 92% sure. And they also said dessert and powdered sugar. And then here's an example of a face detection response of a picture I took with a friend. So you can see it returns the result of the emotions it detected. We can see that joy likelihood was very likely. It also returns a landmarks object, which includes a bunch of different features in your face and the XY coordinates of where those are in the image. So now let's jump into live demo number 2. If we could switch to my computer. So I'm going to minimize this app, and I'm going to pull up this. Actually, I'm going to stop this from running. I'm going to pull up the bot app. And I'm actually going to have Kathy come on up here to demonstrate this. So Kathy here has a bot. And I'm going to run this app. And we're going to be able to see what the bot is looking at. So this, I believe, is bot number 5574. And we can see that she's holding up a flower to it. The lights are throwing it off a little bit, but could be a Christmas decoration. Daisy family, there we go. So there's the bot in action. Thank you, Kathy. That was awesome. So this is what the app is doing. It's got a list of all the active bots. I can click on them, and then I can see what they're looking at. So that's kind of an overview of what the app does. Now I want to walk you through the code so that you can see a little bit more complex app built with Firebase. So first I want to show you the table view controller. So here we set up our Firebase reference. I've got a helper class to do that. And we want to have a variable with the bot ID because we're going to use this when we segue from the table view controller to the detail view controller. We want to pass that bot ID so that we can create our new Firebase reference. And then we also have our local bot array of fdata snapshots. So the first thing we want to do is in view did appear, we're going to attach our Firebase listener. And we're going to say bot ref. And Firebase has a couple querying methods, which are pretty powerful. They let you query by an arbitrary child key in your Firebase. So here I'm doing a query ordered by key. And remember, all the keys here are going to be that list of bot IDs, which you saw in the slide. And I only want to query the bots with ID starting between devrel 5 and devrel 6. All the bots we brought to this event have an ID of devrel 5 with some other numbers after it. So I've got this query here. And I'm listening on the value event type. And the first thing I do is I clear that local bot array. And I'm going to add all the new bot data to it. So I'm going to loop through the bots for bot and snapshot.children. I'm going to say let bot snap equal bot as fdata snapshot, since we know it's going to be of type fdata snapshot. And then we're going to append that to the bot array and reload the table view. That's how we set up our table view. Here is where we write the code to configure the cell. So in this line, we're configuring the cell. And then remember the cell on the left side, the text on the left was the bot's ID. The text on the right was how long ago the bot was active. So here we've got the bot timestamp. We're grabbing that from Firebase. It's stored in Firebase as a string. So we need to actually calculate how long ago the bot was active. So I've got a helper method to do that. And then we want to configure the cell. We'll set the text label to the bot ID. And we'll set the detail text label, which is the text that appears on the right, to the active timestamp. And then we want to change the background color of the cell depending on how long ago the bot was active so that it displays green if the bot has been active in the last minute. And then the next thing we do is set up our segue. So here at did select row at index path, this is called whenever a user selects one of the rows in our table view. We want to prepare our segue. So we're going to set the bot ID to whatever bot ID was selected. And then we're going to perform the segue bot list to detail view. And right here is where we do that segue. So in our destination view controller, which is going to be the bot detail view controller, we're setting the name on that view controller to the bot's ID of the bot that was selected. And then here's just the functions we use to set up our table view with our bot array data. So once we perform the segue, we're here in our bot detail view controller, which is pretty short. So in here, we're just setting the title, which is just the heading on that view, to the bot's name. And then we're creating a new Firebase reference. So this reference is going to be /bots/ whatever bot ID we're viewing, devrel 5 in this example. And then we're adding another Firebase listener to listen to the data only for that specific bot. So bot detail ref.observe event type. We're listening on the value type again here because we're not adding new data to this node. We're just resetting the data every time a new image is taken by the bot. So we're grabbing all the data returned from the Vision API. We can think of this as the bot's world. So we store that with the key of world. And then we base64 decode the image, since we're storing the base64 image string in Firebase. And then we get the labels that are returned from the Vision API. And we loop through them and we display them. So the description is going to be whatever the label was. And then score is going to be the confidence score from the Vision API. And we're going to display that as a %. We add that to the label string. And then we just add some styling to the UI label. So again, I just wanted to show you, an example of an app built with Firebase that's a little more complex than just real-time chat. And we can see that this is super easy to do. I've got a table view controller and my detail view controller. And all the data is displaying in real time with Firebase. So if we could go back to the slides. So just to recap, This is what we covered. We started with an overview of Firebase. Then I talked about how to get started with Firebase on iOS. And we did one demo of real-time chat, showed you how to update a UI table view with chat messages stored in Firebase. And then we did a second demo with the help from Kathy, thank you, Kathy, to show a bot visualizer app that I built to visualize all of the active Cloud Vision bots and what they're looking at that point in time. So if you want to learn more, the Firebase documentation is a great place to go. They've got awesome docs for every platform, iOS, Android, and web, with detailed guides on how to do all sorts of things with Firebase. And then if you want to learn more about the Vision API, if you go to the Google Cloud Platform GitHub, the Cloud Vision repo has a bunch of getting started samples in all sorts of platforms to get started with the Vision API. There is an iOS sample in Swift and Objective-C. And I encourage you to get in touch with Google Cloud. You can follow us on Twitter. We have a Slack channel. And then we've got a bunch of samples for all sorts of cloud products on the Google Cloud Platform GitHub. And thank you all for coming. That's all I got.